Hello everyone, welcome to my shop. I'm Robin. Today we are going to do the Precision Ground Flatstones. Finally going to get to this, and I think these flatstones are probably one of the most essential pieces of equipment to have for precision tool making, working with any kind of precision instruments or parts, fixtures, gauges, vices, anything that you're going to work with that has a possibility of having a burr on it. You really should have these Precision Ground Flatstones. I didn't invent these. I became aware of them from Professional Instruments. I bought some Professional Instruments air bearing spindles for a company I used to work for, where we were doing some very precise rotary spin grinding of spacers. And the spindles are absolutely phenomenal. They're sub 1 microinch TIR, yes, 1/1,000,000th of an inch TIR, and they just are just an unbelievable piece of equipment to work with. Now, in the process of using those, they recommend Precision Ground Flatstones, and the people there are very helpful and educational. If you're someone who's interested in prompting them for every bit of information they're willing to give you. And they said the flatstones are somewhat of a must for assembling these things, mounting them. You have to be very careful about not distorting the air spindle frame or the spindle itself, because they're talking about extremely small clearances that these things operate under. So the flatstones, back when I bought those spindles, I think were in the $250, $300 range, and now on Precision Instruments website they are $500 a pair, and that's a little steep, and there's really no magic to them other than diamond grinding, surface grinding the surface of the stone so it's perfectly flat. In my opinion, and that's all it is opinion, there are no other methods to do it that work. You can't lap them. It doesn't matter what you. I've tried lots of things. Doesn't mean that it's not possible, but I've tried all the other things to make it work, and it just doesn't work. You need a good surface grinder, diamond wheel, and you need to diamond grind the surface of these stones so that they're perfectly flat. The whole principle of this is that the stones have almost no bite. These stones are literally to only shear off burrs that protrude above the surface. Think of them as a heavy-duty gauge block stone. Why is the absolute flatness essential? It's because the nature of abrasives, grinding, cutting tools, whatever, there is a pressure required to make a cutting particle, cutting edge, actually initiate a cut. Below that pressure, the part will just the cutting particle tool will only skate and not engage to any appreciable depth. And then you have to reach this threshold pressure to get where it'll actually bite in and start to cut. So in regular stones that aren't very flat, and they have been dressed by normal methods, they have surfaces of the particles that are sharp and can dig in readily, and because they're not perfectly flat, when you apply pressure, the pressure is only hitting on a very small spots, and that allows the actual pressure at the particle to get high enough to get that cutting action going. When you have a stone that has been diamond ground, you have basically machined off all the particles. The natural cutting particle shape of the particles in the abrasive stone are no longer there. You have a flat plateau. All the plateaus of all these particles, all the particles are obviously in different orientations and different heights. So you're going to get ones that are cleaved off in the middle, ones that are knocked off on top. The principle is the top of these particles is completely on the same plane. They're all flat. so that the only abrasion that can occur, because there's so much surface area engaged, that it's impossible to get enough pressure to get anything to actually dig in. So what happens is the plateaus just glide on the surface, and what happens when you have a small burr, that burr can poke up into the pores that are still in the stone and get sheared off. It's not a big sharp particle coming along and hitting it. It's just the asperities as they're called, dense, raised metal, whatever you want to call it, rising, being able to get up into the stone and penetrate up into it. The paper that I will give the link to from Professional Instruments in Penn State shows some of the testing they've done that's showing how a precision ground flat stone actually improves the surface finish of whatever you stone it with. Now, one of the things that is critical about precision ground flat stones is you must have two. Why must you have two? Well, as we all know, metal particles just love to embed into stones. It's impossible, no matter how careful you are, no matter what you do, you are going to get metal particles embedded in the stone. You're not worried about getting them out. All you do is take the two stones, work them on each other. You'll feel the particles that are embedded getting sheared off, anything that's stuck in there, until you get this smooth gliding motion on the stones. Once you've done that, then you go in the part. So the procedure for using the stones is always, it doesn't matter if you've just stoned something, you go to stone something else, you always stop, rub the stones together, and to knock any particles down. And the embedded particles, you'll look at I'll show you some pictures of the stones, and it's full of embedded particles. They don't keep the stones from working. The nature of this is completely contrary to normal stoning, like mold polishing or things where you want the abrasive to be aggressive, you want to be able to remove some material. This is a completely different tool. Just because it's made out of stone, forget normal stoning. This is its own thing, and once you get used to using these and see how valuable they are, I'm pretty sure you'll agree. You can buy the stones for, on sale, $15-16 for the stones. The stones that are used are the ones that are the orange India on one side, and I think I'm not sure what the other side is, whether it's crystalline or whatever. But the important part is the orange India side is the side that is the most, I find most useful. It's the finer side of the stones.
Here's an example of something that you would not want to stone with anything but a gauge block stone or a precision ground flat stone. This is an optical flat, and I'm using a monochromatic helium light source, and those bands are showing that this thing is easily within 10-15 millionths straightness, flatness in the one direction. In the opposite direction, there's actually maybe a 10 millionths gully on purpose in where the screws are. I will demonstrate that by moving the optical flat to the opposite position where I can show the crossways. I'm intentionally manipulating the angle of the flat to show the flatness in the other direction. So that's a good clean 10 millionths gully that you're seeing in the bottom. And that's on purpose so that this thing sits firmly on the two outer edges. So it doesn't affect the usefulness of this. It's actually on purpose. This was hand lapped with a small block lap to correct these things. So this is an example of a very finely finished gauge. This is a 246 block. I'll turn the lights on now so you can see it. So this is a 246, excuse me, a 166 block that I made to match my other 123 blocks, and this is square, parallel, and everything easily within 20 millionths. So a very handy thing to have, but this is a prime example of something that you do not want to attack with anything but a precision ground flat stone. So I can take my precision ground flat stone and do my normal technique where I make sure that this is very clean and smooth, and I can make sure this is clean come up on here, and I can stone till I'm blue in the face. I am not going to hurt this thing or decrease the surface finish. It'll just remove any burrs that are on there. And this is what these are designed for, and other work that doesn't have to be this precise, but this will not hurt the surface, and it won't change the surface. It won't put any lay of scratches on there. It will just maintain this beautiful surface. So that's a prime example of that. Something like anything from Schmidt that has a beautiful lapped or ultra ground surface on it is something that you don't want to touch with anything but something like a precision ground flat stone. Here is a scraper's block. It's just a block, tool steel block, hardened and lapped parallel, and it's used for bridging the topography of scraping such that you get a smooth surface that you can indicate on to get a consistent reading. So just something that has a surface finish that's better than just a plain surface grind. You can see the reflection there of the meters in the background. So we can demonstrate the effects of precision ground flat stones versus the regular stone. So precision ground flat stone here, working it on itself as always before every time you touch. I'll come on here and bear down. I can put all the weight I want on this as long as it's nice and even, and this will not remove any material. It's only going to burnish and brighten what's here. Okay, so wipe this off, and you can see there's the sheen on there is actually improving, and we can go in here forever. It doesn't matter which direction. There is no lay to what we're doing here because this isn't removing material. It's literally just gliding over the surface and only removing something that might be poking up from the surface. So you can see what's going on there. You can see the finish, still reflective. It's not a mirror finish, but it's typical of what might be on a sign plate or a precision vise. Now I'm going to take one of these stones out of the box, something that people would typically use for stoning, and I'm going to take a stroke on here and just listen. Now look, there's what we don't want. We are not trying to remove material here. That basically has removed material, and you do that every time you stone that, you're going to start influencing the shape of your parts, your sign plate, your vise, whatever. It's not what you're after. That's the purpose of surface grinding these, and that's the beauty of the precision ground flat stone. Here's a piece where I want to show you the techniques using these. I'm using the coarse side. You don't have to match the sides. It's just important that you use the two stones against each other. It doesn't matter if they're coarse to coarse, fine to fine. So I'm rubbing these together. I've got a good sound. I know I don't have anything going on the stone. Coming over here to an unknown piece, unknown condition. You always want to clean it off. It's best that it's degreased, or at least not oily, and so it doesn't make a pasty film. When you come on here, you want to feel for what's going on. And right now I'm feeling, oh, I've got some big clunkers on here that are actually going to require some work. So I'm just using the weight of the stone. I take a look and I'm saying, oh, okay, ooh, I see I've got a raised mark right there. I've got a dent here on the corner, and I've got an actual dent right here that I'm working on. Okay, so I'm identifying that, okay, I've got stuff here that's carrying on. So until I feel that I've gotten down to where I've got the worst of that off, I don't put any real pressure on the stone. Once I feel that I've removed the majority of those, and I'm starting to get where I can feel the whole entire stone starting to bear, then I can stop, take a look, see what's going on, and I say, okay, all right, big shiny here. You can see where that burnish is. Over here is the other one, and there's that dent. Now you can see how it just polishes off around that dent. Now that dent might be a little high, and I'm going to show you a technique here that's pretty important to be aware of, and that is, as we talked about, the reason these don't cut deeply is because there's so much surface area engaged that you'd never achieve the unit pressure required to get the cut to initiate. So when you have something like this, you cheat. come over here and you take your corner, you don't lift the stone, but you put all your pressure on that corner, and that allows you to get much higher pressures than you normally would in that area. And I'm actually going to flip over, go to my other side. Notice I never ever touch the work without stoning first, stone on stone. Now I can come in here and I can bear down on that corner where I can get higher unit pressures because it actually tends to tilt a little bit. I'm doing this slowly because my camera's going to shake if I don't. So then I can take the gentle rub on this whole thing. Okay, now one of the things I want you to take notice of is this flat stones are marvelous at showing you how crappy your grind is that you thought was so wonderful. You start to see your wheel hop from imbalance. You start to see your stripes from your cross feed, and your wheel has a little shape to it. And all of a sudden the grind you thought was so hot all of a sudden isn't so hot after all. So it's an excellent thing to analyze your grind, see what's going on, because this really makes it obvious what's happening. So as you can see there, now that burr is gone, it's burnished off. We've also burnished the peaks. Now like I said, the reason that this stone is removing some material off the tops of these is because since this surface area actually is not as great as you would think it would be, because there's a lot of small peaks, those small peaks are getting abraded away just like these did. But that's the controlled nature of how these precision ground flat stones work. Now this is smooth as glass. This will go on the chuck, or a mating part or whatever, and you can see that it just removes the burrs beautifully. Another place that you might not think of using these is they work extremely well on cylinders and tapers. Here's a Cat 40 tool holder, and has a half decent finish on it. It's pretty nice. And I'm going to be able to stone on this and just ride on this, and you'll see that I'm not removing any material, but I'm brightening up that surface, and I'm removing all the little just minute nicks and things from just dust and things that in the air that get on these and go in the holder. And I'm going to show you here at the end when I get around this that these are not super high quality holders, and I'm going to show you where I can see, because of this and the fact that it's bridging, I think you'll actually be able to see where this stoning has revealed the actual traverse bands of the grind. Now, it's not the greatest grind on earth. It's not bad, but you see the spiral bands here from the traverse grind. That's the precision ground flat stone is only hitting the peaks of this, and because there's peaks here and the unit pressure is getting high enough to remove some material, it's actually brightening up that surface and making the finish or lack of good finish more obvious on these. So very good on cylindrical parts and tapers. You can actually run this in a lathe and gently stroke these and do a nice job. You can literally stone the taper on your grinding, your surface grinder arbor, the spindle itself, and stone that for any burrs using the ground edges of the stones. Once you get used to these, there's just no end to the places where you use these to remove minute burrs. There's another place where, if you're very careful, the precision ground flat stone is great for knocking burrs or nicks from calipers if you bump them or drop them and you get a burr on the edge. This is something that you can rest, line up on the surface, make sure you're good and parallel, and just give a slight rub, and you can feel any irregularities, and it will deburr all of those burrs or anything that's on the edges without removing any significant material. This measuring end of the caliper can often get beat up pretty severely, and you can feel, just when you slide on here, you can actually feel the any burrs that are on there, and just removes the high spots, places where it was dinged, probably making it better than it was originally ground. Same way on the tail end. This is something you can sit on there. You got to really use good feel here. You got to be able to sit on there and feel when you're actually square and slide on this without moving it, and that takes some skill. No getting around that. If you don't know you have those skills, then don't do this, because you can make things worse in a hurry. But if you're used to being able to feel when the stone is flat and not influencing it and making sure you're staying seated, go for it. It's typically a lot easier with a lot smaller, a lot thinner stone. It's not just hardened items also. These work perfectly well on softer material. Obviously, since they're good for scraping, they're good for other things. This is my my gang tooling setup, one of the holders for my gang tooling setup that I've made. And everywhere that you put something down on the gang plate itself or the tools, we take these, we knock all the burrs off, and you can just feel things just slide and the burrs disappear, and it just really makes things work really well. And obviously we stone the whole gang plate off before we start our setup. So here are the flat stones that are about the size that Professional Instruments sells, if I remember correctly. So these are like 1 3/4 by 4, or for the metric folk, 100 by 45. And these are dirty. And actually what I'm showing you is in the dirty condition before I stick them in the ultrasonic. Here's the orange India that I'm talking about, and whatever the other grid is on the other side. These are well used. These get, like I said, every time something goes in the grinder, every single piece, every part, everything that gets gripped gets stoned. So as I mentioned about the embedded particles, see all the shiny spots there obviously are little pieces that are embedded. And that's not a problem. That's why when you put the stones together before each use, you put these and work them on each other. You can even hear the sound difference there as they started. And you can just feel all the embedded particles get sheared off and smoothed over, so that now we've got a smooth plateau. Then you take from this condition here, then you can go stone. And obviously if you're going to stone something else, you do it again, because they just pick up stuff all the time, just stuff falling from the air. On the back side here you can see some big shiny pieces from the coarse side. The coarse side works really well for rough scraping, and then for finer scraping we use the other side. Here's an example of some scraping that has been stoned with the orange side. Now, you can see that doesn't look like your average scraping. I'm talking about the actual sheen. That's purely because of the stones. That's the kind of finish that you end up with. Sometimes this is called in scraping, once you reach the limits of what you can measure with high spot blue. You do pinpointing, where basically you look for the burnished plateaus, and this basically helps in that. You can see how reflective that is, and that's the power of the flat stones. If you used your normal knife edge stone on that, it wouldn't look anything like this, and you'd be destroying the geometry in the process. Here are the same flat stones after a trip in the ultrasonic. You can see that it's removed a lot of the black and dark and really cleaned the pores out. Ultrasonic cleaners do a really nice job on stones of any kind. These would probably come a little bit cleaner if I used, this is just a water-based solution that I use in my cleaner all the time that leaves a non-rust film on metal parts. But if I did these in alcohol, they would come even a little bit brighter, but we know what's the point. It's only going to get dirty again. So this is more than clean enough, and you can see it's really cleaned out the pores in the material. Now this is a good chance to see some of the embedded metal. You can see chips here. Sometimes you just come in here with a X-Acto blade or any kind of piece of sharp object, and you can actually pop some of these out. The huge pieces, you can just hit them from the side, just kind of poke in a little bit and pop them out, and that's all you have to do. If you get some large ones, there's some here on the sides from rubbing the rail of the surface grinder. But these actually don't keep the stones from functioning. Like I said, that's the whole point of being able to rub these two together, is to get rid of any hear that smoothness. Now listen on the other side, and you'll hear some crunchy, and then that was that little place where I popped that out had its own burr, and then you get the smooth action, and that's when you're ready to go in the part. So this is a good chance to look at the lip that I have on mine. This is something that is not on the stones that Professional Instruments makes. And I do this lip so that when you have something like a V-block or the relief groove or anything with an undercut, that the stone goes through and can get and hit the entire edge. Without that, you can have a chance to leave a little tiny radius in a sharp corner or whatever, or in an undercut corner where the stone doesn't quite make it to the edge. This way it reaches underneath the reference rail of the one you have on your surface grinder. Unless you make sure that you're stoning all the way to the surface where the part's going to contact. On these stones I did the lip on both sides. On the next big set that I'm going to actually show you grinding, I'm only going to do them on one side so that the other side can be used for shorter tapers or things to make it a little more useful. When you get these stones, these are as received out of the box. These are 6 by 2 by 1 stones, and then I have an 8 by 2 by 1 stone over here. These larger ones are for just larger parts and also for scraping, where the larger stone bridging more surface area just helps in deburring the scraping and basically acting as a flattening agent in itself. You look at these, you'll see I'm holding these two together. See the gap there on this end and this end? That's how out of flat they are. And on this side, you'll see same, well, huge. So when you go to grind these, when we put these on the grinder, we're going to have to make sure we shim these so that they're not rocking when we're grinding them. And we're going to need to rough these down on both sides to relieve any stresses in them so that when we do the final grind, they stay nice and flat. Sides typically are going to be slightly better, and you can see that they are better. So we'll go over to the grinder and set up to do these. We are holding these stones on the chuck with magnetic hold downs. Similar principle to hold downs used in a vise, which pretty much you hardly ever see anymore, but they work well. This is the same principle except for magnets. There's a slight bend in this. There's a flex section here. Principle is this part gets sucked down tight to the vise. This part wants to, but because of the angle as it rolls down in, it pinches the part. The angle here is just like fingerboard on a table saw. As this thing's moved this way, it tends to self-grip, and the individual pieces allow this to conform somewhat to undulations in the surface of the part. If you go to make this is literally just homemade. This is a piece of 60 thousandths or 50 thousandths spring steel. If you make these yourself, one thing to remember is that things like spring steel have a severe grain orientation to them. And it's very important that that grain orientation is running in this direction, axial to the flexure. If you run the grain this way, if you flex this very much, this will crack, because the grain is just like grain in wood. If this was wood and you had the grain running this direction, you pop it this way, it would just crack instantly. If the grain was running this way, the individual fibers would have to bend and it would hold up. So important note for that. This is only about 5 thousandths thick right here. And so that's the principle. They do sell these, and ideally, especially if you have a large pole chuck, these should be thicker so that there's more lines of flux pass through them so they hold tighter. But these actually on this Ceramax chuck work just fine. So when you put these on, you load, you press down, but you push hard against each other so that you're getting it right off the bat, and then you turn on and just make sure that they don't pop flat. If they suck flat, you haven't put enough lateral pressure on them while you're holding them. Now these stones, as is, are all kinds of shapes. They're just definitely not flat. So I'm using kinematic principles here of 3 points. I've got 3 pieces of 15 thousandths plastic shim stock stuck under this in a 3-point situation so that this is stable, and a block back here to take all the axial forces from the grinding wheel. So this is good and solid. It's not going anywhere. I have pencil marks on here. You don't want to use a marker because a marker sucks down into the stone and won't actually disappear. So this is just pencil in here to make sure that I get cleaned up completely. I'm going to rough this by doing a full wheel width and plunging until all the lines are gone. Whatever that depth is, I will repeat that across as I go across here. Plunging allows you to use the full face of the wheel and not get a bunch of edge wear on the wheel and change its shape drastically, such that when we go, after we've roughed it, then we'll take a nice slow traverse pass across here to get a nice flat surface. There may be stresses in this when I relieve this side, when I grind this off and flip it and grind the other side. There may be stresses, so we may have to do this a couple times till it lays flat. It's been so long since I ground the other one, I don't know if these tended to move or not. So we're going to tear into it here and fire up the grinder and get grinding. These hold downs can be contrary at times. I'll give you an example here. When I turn this on, by chance this just happened to stay, but a lot of the times these will slap down and they won't be getting enough grip on the part. And I'll show you a little technique here that works really well, is to take something non-magnetic. This happens to just be a couple pieces of phosphor bronze, and slide them under your leading edge of the parallel so that it keeps it propped up even if it doesn't have a grip. Push your parallels in, snug them, turn your chuck on, then take your brass and just gently tap with your finger down here on this end. You're feeling for this to skid. Okay, I can feel that I'm actually moving the whole assembly now. Now you can pull these out, and knowing they've got a bite, and now the magnetic pressure is pulling down on the edge here and getting a bite on that and pulling the part down to the chuck. Using a 1/2 inch wide, 7 inch diameter, 150 grit resin bond diamond wheel, I'm plunging full wheel width down until the whole part cleans up, and move over a wheel width, and then once I've gone back and forth and cleaned up there, I traverse pass across there to get a smooth finish. You traverse pretty slow, and then when you're all done there, you can feel the surface, and it should be baby butt smooth there on that. Now we're flipping over to the other side. I've stoned the chuck and putting the stone on the chuck, feeling for smooth. Going up against the hold down on the back, got my stop block on the left-hand side of the part, putting the other hold down on, pressing firmly against it, turning the chuck on, making sure that they don't pop down and I've got a good grip on the part. And pencil lines on the outer edges so I can tell when I've cleaned up. Okay, we have the vise on. We have parallels sitting here to support the edges of the stones. They're on an angle to straddle the poles of the chuck so that they'll actually hold. If you don't straddle the poles, you won't get any magnetic holding power. And we'll grind this side flat, and then we'll flip it over. I have flipped these over to the other side. Now I am about 40 thousandths away from the center line of the two stones. Plunge down 20 thousandths, moved over a full wheel width, plunge down 20 thousandths again, and then to come back, take a few thousandths depth of cut, plunge in, and then traverse across slowly to get a good finish on that surface, which will be used against the reference rail. Here's a view of that lip. The two stones obviously are against each other, and that lip is about 20 thousandths deep and just allows you to get underneath reference rails and edges. Need to break the edges on all these because they're very sharp from the 90 degree. Pretty heavy bevel out here with a diamond file, round the corners, round over the corners here, and just so that these don't pick up and catch and also don't chip as easily. Just as a little check, it's interesting to see if these hinge at the 30% point, if they, like they should, and you'll notice that these are hinging very nicely at that 30% point, and that's just because they're as flat as my grinder grinds, which is pretty flat. So that's just another check to see how they are, whether or not you got them. These can be affected by whether or not you relieve both sides first. If there's a real big bow and you take a lot of material off, these are no different than any other material. Huge material removal on one side is probably changing the balance of stresses in the part. Therefore, you need to take another cut on the other side and spring cut, if you will, and go back and forth until you know the part is sitting still. Here's a view of before and after grinding on the coarse side, and a view of before and after on the fine side, just to give you a visual reference.